Okay, good morning, everyone. Welcome to today's MLT Week 3 session. Okay, first I'll show you like how you can search uh, every session. Maybe some of you are saying that you are not able to find the recording or anything. I'll show you. Okay, let's see this. I mean, obviously this is YouTube. So let's search our subject. I think MLT or maybe machine learning techniques. We will get. Our, think Yeah, so this is our, I mean, MLT course YouTube channel. So once you will click, no, what happens, no, I mean, we have to add anything in this playlist, then only we will be able to you see it here. Okay. But if you don't, if you click on this videos, no, I mean, once you click on the channel, okay, it is not in the video, then yeah, it will be in the live stream. Okay. Here you see week 3 summary session. Okay.
Okay,
So
okay, sir.
it was a strip. Okay, like this you can see for any week. I mean, for any subject, yeah, and any week's content. Okay, so here you will see it is sorted based on the like when it happened. One day earlier, 6 days earlier, 13 days earlier. Okay, so all yeah, these three sessions were there.
Okay,
What had happened in the week 1 and week 2? I think I had also posted it on yeah discuss that what had happened that in first two session, no, I actually YouTube we I mean on Gmeet we we get three options. First is that, I mean, do the recording. Second is the stream on YouTube. On stream, I mean, locally stream it. So by default it was set as like a local streaming. So okay, that's why I mean, the one session of week 1 and one session of week 2 didn't come. So I took this first session of week 1, but what happened, no, as I told you, that at that time that is streaming, it was locally streamed. Okay, but actually by default we were getting that button, so that's why we just click on that. Same thing happened with this week 2 also, like the instructor who was there. So in the first session he didn't see. Okay, he also got the, I mean, by default button, so it directly clicked it. Okay, so that's why we were, I mean, all of us missed at least the first session. Okay, so we were not able to stream it. Okay, so that's why. But yeah, in the next session, I mean, we had done that. But yeah, now we have informed with every other instructor also. I mean, all instructors. So now you won't face that issue. So yeah, to one session of week 1 and week 2 are missing here, and yeah, we won't be able to help there. But yeah, you can refer previous term session for that. Or if you have any doubt, you can ask us also. Okay, that's not an issue. Okay, yeah. So someone was raising their hand. Yeah, I think is this okay. Okay, yeah, we'll discuss problems. Okay, I think yeah. Okay. So you guys have already shared the link also. Okay, thanks. I mean, yeah, we were saying, yeah, Anjali, Kaushik. Yeah. Okay. So who had raised his hand? Okay. Yanna raised. Hello.
They
Would you
not
like to?
lowered the hands they previously did when you said.
Okay. I'll do that. So, okay. Yeah. So I think yeah. I'll just okay. So you guys want to okay, some other person. Yeah, Manan. Yeah,
Good morning, sir.
yeah.
Sir, actually, I had a doubt. As we discussed, uh, that in kernel PCA, when we are projecting any points from a lower dimension to higher dimension, they usually lie on a in that higher dimension. They lie in a lower subspace, kind of in hyperplane, right? So I wanted to know if we are doing the clustering, and if the cluster centers which are
Hmm.
projected are actually lying in a higher dimension, and sorry, in a plane, supposedly in a hyperplane, a higher dimension, all these points are in higher dimensions, but so, by coincidence all these cluster points, all these means are lying on a single plane, then will it tell us something about the data? Will it share some extra information that what can we do, or can we get something more from this type
Okay.
of
Okay.
representation of data?
Okay. Tell me like whether I'm getting you correctly or not. So what I'm understanding, you are trying to know that if we do the, I mean, if we transform it to the higher dimension, so whether it is giving some additional information or not, is it? or something
No,
else?
sir, we are not transfer. We are only just doing is we are only clustering the data. Suppose the data is in 3 dimensions, but when we are clustering the data, we can see that all the clusters are actually lying on a plane.
Okay,
They all pass through an equation of a plane. So
okay,
where there was some information about the data, that data is somehow behaving in a certain way.
okay. Actually, in meantime, I'm getting some noise, so that's why I think I'm just missing the few points, like what you are saying. So I'm assuming that you are saying that when you transform the data, I mean I mean project it into the higher space. Okay. So in that cases, you are asking what you are trying to ask.
I know, sir, I'm not asking if we are projecting it into a higher subspace or not. What
Mm.
I'm saying is we have the data and we are directly clustering it.
Okay.
And by clustering the data, we get this cluster points means of all the clusters.
Yeah. Right.
So what can we get any additional information if all these clusters are lying on a plane?
Okay. Yeah.
Yeah, this is
So
my question.
can
We are
we
not
get okay?
transforming it.
Can we get okay? So can you get the data? I mean, can you get the information whether your cluster is lying on plane or not? Right?
Yes, sir.
Yeah.
And
So
how can we get
yeah,
some additional
yeah.
information about the data if it is lying on a plane?
Okay. So first of all, lying on a plane means see any plane. Just a minute. Okay. If any data is lying in a plane, it simply means that data has just two dimension, right? Then only it will lie in a plane, no?
Yes.
And it means that you have just two features, x1 and I mean, yeah, this is feature. This is not a data point. A data point you can write it as x1, x2, x3, but you have just two features. Then only your data will lie in a plane. Okay. See what is happening currently. No, you guys are just getting the. I mean, just for visualization purpose here, we are using like everywhere we are using one or two uh, dimensions only. Okay. But if you see, uh, let me, where is that? I think I'm just yeah. So yeah, some of you. So yeah, what you were saying. So what is happening? No, in our MLT course, like ideally just to represent you properly, so that you can easily visualize it. We are plotting every data set into just two dimension. I mean, yeah, we are taking just two dimensional data set as an example. Okay, so that's why if some data set is I mean two dimensional, no, then it will lie in a plane. Otherwise, how it will lie in a plane? Just think. Okay, in most of the cases, in general cases, there would be I think four or five, or at least I mean there will a lot of dimensions. Okay,
Yes, sir.
so yeah, so for your questions answer will be like just to know that whether it will lie in a plane or not. It simply means that I mean whether it is I mean how many dimensions it has. Okay, or how many features are there in that data set. Okay,
Not just
uh,
for
i-
any data points, sir. Not just for data. For data points can lie in higher dimension. It means there could
okay,
be a 10 dimensions, and data
okay,
data points can be well spread across all the dimensions.
okay.
But if we are finding the mean of the cluster, suppose there are
Hmm.
10 data points and the cluster is
Hmm.
mu1,
Let's
uh,
yeah.
and mu1, we can actually have an equation of plane that is passing through mu1 that is possible in higher dimensions. That we can have a plane that is passing through the dimensions.
Hmm.
Okay, and then we are getting more than one cluster. We might be getting three clusters, and all these three clusters
Oh, whether they
are
are lying
having
in a
mean.
plane or not.
Yeah, all these three cluster centers mean of this
Yeah,
cluster,
yeah, yeah.
not the data
Got.
points. Data points can be in higher dimensions.
Hmm.
But data points are not coming on the plane, but the cluster mean mu1, mu2 to mu10 are actually on a plane.
Yeah, it is. I would say it is not always true. Okay, that all data points will lie in a plane only. Okay, I mean all cluster center will lie in a plane only.
Okay, sir.
Okay, are you getting my point? Because see, ultimately those those centers are also like just a data points only. If some data points are, I mean, what I am saying, see, one thing is true that 2 points will always lie in a line. Okay, if there are 3 points, then it will lie in a plane. Okay, but at least if there are 4 points, no, it is possible that they may lie on a plane, they may lie on a line, and they may also lie in a three-dimensional space. Are you getting my point?
Yes, sir.
So yeah, so 2 points we have, then it may lie on a line, it may lie on a plane also. Okay, but yeah, but if you have more than 3 points, then it may lie on a, I mean, in 3D space. Always the maximum point. See what is happening now. See, 2 points, 2 points. Max choice you have is a 1D. That is line. If you have 3 points, max possibly case is like 2D, either line or plane.
Okay, sir.
Okay, it goes like this only. Okay. Uh, okay. So I think you guys are interested to
Sir,
discuss the
even
problem.
2 points can lie on a plane.
Yeah. Obviously, I'm saying no. It can lie on a line or it can also lie on a plane. Okay. For every like 4 points are there, then it may lie on a 3D. It may go to the like it may lie on a line also. It may lie on a plane also. It may lie on a I mean 3D space also. For example, like let's say you have 4 points. It is lying on the line, no? If 4 points are like this, then it is lying on I mean on a plane also. But it is also possible that 3 points are in this plane and 4 points lies on the like 3D space. Okay, so everything is possible. I mean that is the worst case, or maybe yeah, that is the maximum possible cases. Okay, so it goes like that, n minus one, something like that. Okay, obviously it can go to the lower dimension, so there can be cases like all the 10 points can lie in a plane. That is also possible, but yeah, it is not that always it will be possible. I mean as you are seeing here that no, most there are very few chances that it may lie on a plane or it may lie on a line. Okay.
Okay, sir.
Yeah, so I think yeah, so whether you guys want me to discuss. Okay, yes. Yeah, Viraj.
So, sir, actually, I wanted to ask for, say, for example, in 2D, there is non-linear relationship in the data, and we are
Yeah.
trying to cluster it.
Okay.
Okay, then sir said there are kernel methods from which we can transform it into higher dimension, and then we can
Yeah.
see the clusters, and then, but then, sir, won't we have the same problem that we had in PCA kernel, that we cannot write the whole data point down?
Yeah, that is, see, what, yeah, that is also true. Okay, whatever you are saying, that is true. So, see, what is happening? No, let's say, first of all, a non-linear relationship between data, that is different thing. But non-linearly separable data, it is, if it is there, if your data set is non-linearly separable, then you project it into the higher dimension. Okay.
Yes, sir.
Yeah, and again, if you are projecting it to the higher dimension, so it's not a processing technique. Okay, so where, I mean, you had to maybe later you have to lower it, I mean, you have to bring it into the lower spaces also. Here, I mean, you just projected it and then you then you checked like which one is fitting your, I mean, data set. I mean, by which maybe by then you will be able to separate it into different clusters. Okay.
So, sir, say for example, there is a like a relation between the data, and
Okay.
one more cluster very similar with a phase difference of some, means like it is
Yeah,
shifted a
I
bit.
understood your point.
So then, sir,
Okay.
if I'm trying to capture cubic relationship, then sir, the dimension will again become very large.
Yeah.
Then sir, how will I try to cluster it inside the higher dimension?
So I mean, see what happens. No, just give me one second, one second. Yeah. Uh, so what you were asking? So you were, I hope you were asking that. I mean, see, whatever is the case, if you project it to higher data set, no, I mean, at least maybe not if you have data set, let's say any shape you are getting. Okay, so once you project it to higher dimension, it doesn't mean that always you will be able to. I mean, you will able to find the best cluster, optimal solution. Okay, there are cases like maybe, but if you, let's say, if you had two data, I mean, for example, we were seeing, no, I mean, this data set. Is my screen is visible? No,
No, sir.
is it?
No, sir.
No, sir.
No, sir, not visible.
Sorry. I was thinking that my screen. Okay, okay. So this part I had discussed. Uh, this, I mean, at that time also it was visible, no? At least when I was plotting this. Hello.
That time it was
Yes, sir.
visible.
Yes, sir.
Okay, okay,
Yes, sir.
okay, okay. So let's go with this point. So what I am saying, no, for example, let's say you have a two cluster. Let's say, uh, okay, and cluster two is something like this. Okay, it's just an easy. I mean, why we take this example? Why we are taking this example? Because like it's easy to visualize that. Maybe just I'm just drawing the line so that you can get the idea like what type of cluster it will be. So it's easy to visualize that if this is the data set. Okay, currently it is in 2D. I mean, all the points are 2D. So when you will project into the 3D, no, then you will be able to separate it. But no, I mean, but there can be cases like even on 3D also, like at least in once you go to the like one dimension higher, no, or then you easily you will be able to see like you will be easily able to separate it into the different cluster. But there can be cases like where in the in the higher dimension, at least maybe in the 3D, no, maybe in 3D you were not able to cluster, I mean, separate it. Maybe in 4D you will be able to separate it. But there, I mean, no one is giving you guarantee that if you I mean, if you maybe if you, I mean, project it into the higher dimension, then you will be able to I mean, separate it. Okay, I mean, separate it into different cluster. Okay, for example, like you were talking, there can be cases like where, I mean, even after going to the higher dimension, you are not able to cluster it properly. I mean, properly cluster it. Are you getting my point? I think.
Yes, sir. So,
Okay.
but I'm asking that, like here we see that there might be a quadratic relation in the data point
Yeah.
in cluster one, say, and cluster two
Okay.
also has some other quadratic relation. So I transform it into 6D, like we saw in kernel PCA. But
Hmm.
sir, like say for example, here 6D is still manageable. But if we are trying to fit it into some if say for example we have 1,000 dimensional data and we want to try to fit it to three means like three power um, uh, relation, then sir what will happen? Then sir, if we can't see the data points themselves, then sir we
Okay.
will get lost in the higher dimension.
So you don't see here you why we are plotting it, so, just because just to visualize it. But no, I mean, see, algorithms are there to do this. Okay, I mean, it's not. I mean, obviously, anything if you visualize more than 3D data, no, it is very difficult to visualize that. Okay, so once you go above 3D, no, it no need to visualize. But there are algorithms, I mean, which is doing that calculation. Okay,
Yes sir.
yeah. So
Sir,
by yeah,
sir,
yeah.
in one session, I heard that students who not attended the session with student email ID should not be allowed into the meet. But some people in this meet are.
Okay, maybe there are people. Okay, so basically, what had happened? No, in one of these, maybe there are few people like who were from ITM, and so we had to allow them. So that's the thing. So if there are people like that, I may need to check. So
No,
that's why.
there are some people out of the
Okay,
see
okay.
the
I
yellow,
mean,
the yellow mark above.
okay. Yeah. So what is happening? No, so there are people. What is so Harshal? I think maybe he would be from ITM. Is it Harshal? Yeah. So basically, Manan. Yeah. Okay, if he is, I mean, just normal person, then yeah. just and you're using your ITM given. So what is happening? So why I am allowing few people? Because like what is happening? So there are few people like from ITM offline degree. So who has taken these courses? So they don't have our SML ID. Okay. So that's why I mean I'm allowing others also. Like I didn't see that whether his I mean ID was this one or not. Okay.
Okay,
I mean
just the
whether yeah.
institution said we should not allow like that
Yeah,
to
yeah.
enter TA.
I
That's
understand. I understand. I'm getting your point. Yeah, and that is true. No, I mean, obviously, other like if someone is coming from other IDs, then I can't control like what he's saying or what he's speaking. Okay, so there can be that guy or can create some issues. Okay, so yeah. Apart from basically currently we don't have any options. I mean, since there are few, as I told you, no, there are people from IITM. I mean, IITM offline campus, so they have their IITM ID. They don't have our SML ID. Okay. So that's why I was just allowing few people. I think, but okay, I think so. I thought that only, but I think he's yeah, he has the ID. Okay. Uh okay. So I think I made my point clear, or any more clarification needed for this one?
No,
Okay. Okay. So if you guys want to me to discuss this one, what you guys, what do you want me? You guys want me to discuss? I mean, should I go with this activity and practice question? So first, okay, maybe first
Actually,
should I go?
activity questions were discussed in TA sessions.
Okay,
We can actually discuss with some practice assignment questions.
okay, okay.
So
I
mostly
can.
we found that activity questions are not that difficult.
Yeah, yeah,
Mostly they are based on theory, but we have. I am specifically worried that this won't be the thing for the quizzes, like quizzes, even the
yeah. So
practice
see,
assignments.
yeah, yeah. Week 3, no, you don't expect climate much more tough questions. So it's just like once you see the tutorials, like how algorithm works, that is more than enough. Okay, for week 2,
Okay.
week 3, yeah, for week 3. Okay. Also, I mean, how? So had you attended previous session? I think yes. Is it Mayan?
So which specific session means I
Friday, Friday,
attended?
Friday, Friday, day before yesterday.
No, sir, I wasn't able to
Okay.
attend that session.
Okay, just maybe then refer that session also, like you will get the idea like how thing works. Okay. Okay.
Okay, sir.
Then yeah, I'll just try to see. Like I'll just try to revise the. Uh, I'll just go through this paper. Okay. I think yes. Okay. Okay.
Sir,
So
there
I
are
think yeah,
also solved with a session with instructor in this course, right?
solve with instructor.
Yes, sir. Like
Yeah.
in
No.
some previous, like
You
in
no.
case
So
was an
current.
MLF, that's why I'm asking.
Yeah, yeah, yeah. No, for this course, no. I mean, usually we are keeping. I mean, there are tutorials for the session, and other than that, what is we have this one. I mean, open session, and then maybe we discuss. Most of the sessions are like open session and summary question, activity and practice questions. So earlier, like, what had happened? No, earlier how they have planned it, like the first day we used to give some summary, and then we used to discuss. Uh, Programming assignments, but we were not getting enough people for those when we used to discuss programming assignments. So then I think yeah, we skipped that part, and in both session, like it's first session is like a summary session, and second session is like open session. Anyone
Okay,
has
sir.
any doubt there, it is like that. But yeah, since I think in the previous, like when I was taking session in week 1, then I found that many of you said that just keep the first session as a summary session, and in the second session we can discuss practice questions or activity question, anything like that. Okay. So that's why I mean in week 3 I'm just trying to follow that pattern. So first session I discussed the other thing. Yeah, I just revised the concepts, and in the second, in this session, I'm just planning to discuss the questions, activity and practice question, and maybe and some open questions, whatever you guys will ask. Okay.
Also,
Okay.
some of the solve with us questions are being solved in TA sessions also.
Yeah, yeah. So in TA session, they will solve the question. So what we have said to them, no, just I mean, just compile few questions and discuss it based on your review only. Like there were a few people, like some of you were saying in the we are not getting enough enough questions for practice. So then yeah, we planned that yeah, our TAs will discuss the questions. I mean, they are working on it. Maybe from this week onwards, I mean, they will just come up with some slides of questions and they will discuss it.
No, they
Okay.
have started. They have started. Like on the
Oh,
last UTA session I attended, they were doing the solve with us also, and they've also solved some previous year questions. So,
okay, okay, okay. Yeah.
so others, if they want to join, they can join the TA session for that.
Yeah, definitely. I mean, see, TAs will discuss the question. So if they have already started, then that is well and good. Yeah.
Yeah.
Okay. Okay. So shall we start now? I think, yeah, I'll just cover it like whoever has missed the previous session. So just maybe in 10 minutes, I'll cover what all things we have. So in week 3, basically we discussed the like how k-means clustering works. So basically, the k-means clustering job is to identify the similar set of people and cluster it into the different groups. Okay. For example, in the last session, also like we discussed, some of like one of you had given the example of like clustering people into different groups based on their marks. Okay, or based on their grades. Okay. Let's go with this example only. I mean, maybe whatever I'll say, I'll discuss. I mean, I'll take this example only. Okay. So what is happening? No, I mean, so let's say in your class there are 100 people, and they have got some marks. So how you are how they are you are clubbing them into the different group? Maybe by their grade, S, A, B, C, D, or E. Okay, like that. Okay, so you have predefined criteria. So here you are doing this. Okay, you are giving them grades. But what happens with this PC algorithm? No, I'm sorry. What happens with this k-means clustering algorithm? No. Yeah. So what happens with this k-means algorithm? So you give you what you did, like you just gave them you just gave your, I mean, let's say in your class you have 100 number of people, okay, and they have got some marks in MLT paper. I mean, obviously marks will vary between 0 to 100 in quiz one. Okay, let's take example of quiz one only. Okay, in quiz one, okay, and you gave this as an input to your k-means algorithm. So what k-means will do here is that it will just take every I mean every person, and it will try to find some try to create some cluster or some groups between the students. So how many groups it will create, it depends on you. Whatever the input you will give to this, no, I mean you will say that hey k-means, just give me 3 groups of people. I mean, just divide all of them into 3 groups. So maybe by finding some relationship, it will divide them into 3 groups. Okay. But if you are saying that divide them into 5 groups, then k-means will I mean, based on their marks, it will divide them into 5 groups. But what if along with marks, I've also given their gender? Okay. So what is happening? Mark, earlier we were talking about. Okay, let's take it. Let's take three example. Okay, 3 samples. Okay, maybe x1, x2, x3, x4, x5. Okay. Marks 50, 85, 90, 70, 20. Okay. So first what had happened, I have given them just input as a marks. Okay. And I asked k-means to create 5 groups. Okay. Okay. Or maybe let's sort it. Okay. I asked the k-means to create 2 groups. Okay. Then what k-means will do? It will, based on their marks, it will divide them into 2 groups. Maybe here they can divide like a 0 to 50 into one group and 50 to 100 into another group. Okay. And once we let's say we have one more features here. Just take it. Okay. Gender. Okay. That's it. Okay. Gender. Okay. Male, female. Okay. Female, male, male. Okay. Anything. Okay. I'm just putting it randomly. Okay. It is like that. Okay. So now what will happen? Now this data set is like a 2D data set. Okay. Here, let's say this is male, this is female, and this is like a 20, 40, 60, 80, 100. Okay, so 50 is somewhere here. Yeah, 50 male, 85 female. Okay, somewhere here. X3 90F. Okay, okay, 90F near to here only. Okay, okay, and X4 70M, 70M. Okay, 20M also. It is like that. So what K-means will do? Again, it will try to create two groups. So maybe in the first group, these people will be there. Second group, these three people will be there. So here, we can easily see that most of the people like who are getting lower marks are there are they are male, or at least the people like who. So basically, what K-means will do? K-means will try to identify some pattern. So what based on their points distance, it just created a group. Okay, created a cluster where it kept all these 3 points in one cluster and other 2 points in another cluster. Okay, like that. That's how K means clustering worked here. Okay, so it was easy to visualize even when we had one dimension data. Just marks as a feature. Then it was very easy to create the group. Okay, even manually you could have created group. Okay, 50 to 0 to 51 group and 50 to 100 another group. When you had 2D data, you created group based on just by plotting into the 2D surface. But let's say we have one more feature. Let's say we have age. Okay, 15, 18, 21, or 19, or 23. Okay, something like this. Okay, now what you have to do? Uh, Here you had their gender. Here you had their marks. So now you have to plot one more dimension. That is their age. And now it is little difficult to visualize, no? Still you will be able to visualize it. I would say that. But at least find cluster, that would be difficult, no? Are you guys agree with me, or I'm just saying something? Is it?
Yes.
Okay. So yeah, that's what I'm saying. So if you have three dimension, then you will be able. Your based on the calculations, you will find the cluster, and yeah, you will plot the points. Okay. So you will find the cluster. Okay. So that's how k-means clustering works. So, but good thing about the biggest issue, or whatever you say, in for k-means algorithm is that it is dependent on two factors. Two main factors. Like what is your initial centroid? Basically, uh, if you talk about the its working process of k-means algorithm. So, okay, I think yeah, we say that. Basically the working process of k-means algorithm, what we do, like we first decide like how many cluster we have to do take. Okay, once you decide, let's say here we have already decided like we had to take two cluster. Then what we did, like we assign each data point into one of the cluster. Okay, before doing that, obviously first you have to first you have to decide like which one you have to assume some cluster center. Okay, maybe centroid or cluster mean, whatever you say. Okay, maybe you would have decided some cluster. Let's use some other color so that. Okay, you decided some cluster mean here and here, and based on this cluster center, you calculated distance of all points from the here, and then you would have assigned all the points which is closest to this cluster. This center. Okay, and again you assign all the points into the cluster 2, which were closest to this cluster 2 centroid 2. Okay, and once you did this, after that you would have calculated new mean. Okay, like this it works. Okay, so these are the steps. Okay, let me go through. I think. Okay, it's just a mathematical way of representing it. I think that's how k-means algorithm works. Okay, and how you decide whether some points should move into new your ultimate aim in k-means algorithm to minimize these distances. Okay, which is nothing but the distance of any point from its own mean. Okay, on clusters mean. Okay, you are just trying to minimize that distance. Okay, once you will able to minimize that distance, then Either you will, you will reach at the local optimum solution or global optimal solution, but no one gives you guarantee that you will reach at the global optimum solution. All right. I think that was the brief about the. I mean, this is what we have.
But it guarantees that it will reach the local optimum solution, sir.
Yeah. That's for sure.
Sir, why will it not reach global optimum?
So it depends on your. Initialization. Okay. For example, let's say uh, what happens no based on your initialization. Okay, one questions we have where we will see. Okay, where we can see that how things are changing based on the initial points. The initial centroids, like our choice of initial centroids. You are not able to reach at the main solution, or maybe you can say that you are not able to the reach to the exact solution. Okay, some different type of centroids. Some different type of cluster you will get. Okay. Okay, hello. Okay, I have just, I think, yeah, one of the example is there in the, I think, practice assignment questions. Okay. So main issue you found that, the issue is that, okay. So your data set, what happens? No, you would be knowing that how much time it will take, how much maximum number of cluster is possible. That k to the power n. Okay, that many number of cluster mini is possible. K to the power n. Okay. So here k is the number of cluster and in the number of data points. So
So
what you
that
have,
is the maximum number of clusters, sir, possible.
yeah, that is, yeah.
Okay.
This is the maximum number of combination possible. Okay, that is k to the power
Yes.
n. That is the
Yes,
maximum
sir.
number of combination possible. Okay, yeah. So okay, and
So
maximum number of
in this
cluster possible is
combination,
n.
n will be the maximum number of clusters.
Right.
Okay, sir.
Okay. Let me delete everything. Okay. So I think, yeah, that's what we have discussed here. This week. So there at the end we discussed like how to choose K. Okay, three topics mainly were there in this week 3. First you decide how K-means algorithm works. Then we got to know that about the importance of like initial centroids. And once we got to know about that, then we came up with this K-means plus algorithm, which is which has some better tricks to get the best. The most appropriate initial points. And after that we explored the ways by which we can we can know the uh, optimum number of cluster, how many number of cluster we should look for. Okay, that was like elbow method, another method. Okay, I think someone was asking something, or someone had,
Sir, I was asking.
yeah, Viraj.
Sir, I wanted to ask, like, say, for example, we have thousand dimensional data, and in this data, we apply k-means for k equal to 3.
Okay.
Then, sir, so basically, can we say that the algorithm will choose one feature in which
Hmm.
it will basically divide the whole data set into 3 parts? There is only one feature which will best fit this arrangement.
Are you clear like what does feature represent, feature means? And
Yes, sir. Like means like there will be one feature which will basically help us like distinguish the data into 3 parts. Is,
uh, see, if you have 1,000 data points, no, thousand data points or 1,000 dimension data set.
yes, sir.
So what are you saying? Let's say you have 1 lakh data points and 1,000 dimension. Okay,
Yes, sir.
so 1,000 dimension simply means 1,000 features. Take it like this.
Yes, sir.
Okay, so if you have 1,000 features, then K means won't look for just one feature. Okay,
Yes, sir. Case means won't look into just one feature, but
yeah,
it will
okay.
try to find such a feature in which the distinction will be best fit. No.
Yeah, K-mean plus plus. No, see, initially, what K-mean, see, I'll just take this example only. Okay, so what will happen? So for K-means, you gave them, give 3 input. you gave like a, you have to do three cluster. You have to form three clusters. You have maybe 1 lakh samples, and all we have like 1,000 dimension. Which simply means you have 1,000 features in
Yes.
your data set. Okay. So what K-means will do first, it will randomly select three points. Okay. If you have given, out of those 1 lakh samples, it will randomly select three samples. Okay. And
Yes.
obviously, all these three samples have 1,000 data points. 1,000 features.
Yeah.
Okay.
Yes, sir.
Or maybe 1,000 for let's say if any point is there in 2D, you have its x coordinate value and y coordinate value. Similarly, if any point is in the 1,000 dimension, it would have 1,000 dimensions value, right? Like x, y, z. And something like that. Okay. So
Yeah.
it will just select three random points, and based on that, again it will start calculating the closest points. Okay. Like this, it will create three separate groups.
Yes. Okay.
Okay. Uh, whether your doubt is clear, I didn't understand what you exactly you are trying to ask. So I just gave you the the briefly how K means will work in this case.
So,
Okay.
means like what I was trying to ask is that, like, say for example, without knowing means like the computer doesn't know, and we know that there exists one feature in which the data is clearly divided into three parts, and
Okay.
rest of the data is homogeneous. Means like random and homogeneous. There is no clear distinction in the other features.
Okay.
Okay,
So
so like
you, yeah, please.
so like in this one example, you said male and female. Okay, so
Yeah, I
male
got
and
your point.
female.
Yeah.
So we know that here there is a clear, very good distinction in the data. There exists one feature which has very good, uh, like that distinction, and the rest
Okay.
of the data is somehow homogeneous. Means like very close and similar. So then basically what k-means will do is that it will find that one feature in which the distinction is most clear, because there might be other features also wherein the distinction will be there but not so clear.
Okay, not so clear and not, very close. These are two different points. Okay, so both in both cases you will get differently. I got your point, like what you are trying to. So let's say you had just take that example only, male, female, and other things. Okay, let's say here, and do not go up to the higher dimension because like it's difficult to visualize. Maybe in lower dimension we can easily see that. Okay, let's say here you had age, gender, and I think marks. So let's just say that gender is clear, like male and female. Their
Yes.
ages are no very. So there can be two cases. Okay, here you are seeing that you can easily divide them based on their gender, right?
Yes, sir.
You can easily group them. Two groups. Here two groups can be easily formed based on their age. That is what you are saying, no?
Yes, sir.
That one column is sufficient. Yeah. Hello, someone was saying something. Okay, so what I'll tell you. So but see, currently what you are doing. Ideally, you are saying that you had three dimension, but now you want you are thinking that your K-means will just divide based on this one feature. It is
Yes.
not going to happen. So but I'll tell you, it is not going to happen. It will happen only in that case when these age differences are very minimal. Let's say something like a 40.1, 40.2, something like that. Very minimal distance, and you have like 1,000 data samples, and the age lies between. The range of this age is very low, and the range of marks is very low. Okay,
Okay.
then in that case, it may divide based on this. Otherwise, but in general, it will consider all the points. Okay, and then based on that, it will try to create group. It is not like, let's say, in the case which we are taking, no. Let's say if you have age between, between 20 to 40, marks between like 0 to 100, and you have gender between male to female, then never expect that it will divide them based on just their gender. Okay, K-means doesn't understand anything. Okay, K-means doesn't understand that it is gender, it is age, it is marks.
Okay.
Okay, K-means simply understand that these are the factors, and based on we have to and K-means will consider all the factors. Okay, that's why there are 2 points. See, in K-means you have to normalize the data. Okay, currently it may look like here it is 23. Okay, I mean age and marks are looks on the similar scale, but KV, what you have to do first, you have to convert it into 0 to 1. Again, I mean normalize it, age data, normalize marks data. Okay, gender obviously 0 or 1, something like that. I mean you will plot. Okay, first you have to convert it into this one. I mean you have to encode it. Okay, because the machine doesn't understand I mean text. You have to convert it into the vectorize it. You have to vectorize it, and then yeah, you will I mean based on the all the inputs, k-means will try to find a group. Okay, k-means will consider every factor. Not, I mean, even though you know that there would be some factors, I mean uh, some features based on which you can easily signify that, I mean you can easily categorize the data. But k-means, see why you are giving every point. So k-mean will have, I mean, so why you are giving every point, I mean all the dimension, because you want k-means algorithm to consider all the data points, no, I mean all the features,
Yes,
not
sir.
only based on, yeah. So that's why that's the job of k-means. Okay, and in only there is only one possible case where, I mean it will divide based on their, I mean gender only, when, I mean all the difference between these things are very small, or maybe let's say that all these age values are same only, marks are same only, then only it will divide based on gender only. Okay.
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 So correct me if I'm wrong, but if we try to like separate them based on the feature, then it won't be unsupervised, right? It's like we are
Yeah.
the label data basically. Like if you're classifying based on the
Right. Right. Right.
and female,
Yeah.
then it's like a label data that if the data set has this value, then it is this, that it comes in this group and otherwise not, right?
You are right. Right.
Yeah.
Okay, so I think you guys are clear about it. So yeah, I just gave you the brief summary, like what happened in K-means clustering uh, topic. Okay, what we learned in week 3. Now let's maybe, okay, since you guys are saying that, I mean obviously activity questions are, I mean easy to interpret. I mean, but at least let's go through it. Okay, so that, I mean there would be confusion. Maybe in 15 minutes we will be able to discuss this also. Okay, so first question says. Okay. Or I mean, how many of you want to me to discuss this activity questions also? Because I assume like there will be 2-3 questions which maybe where we may need to discuss something. Otherwise, I mean it will be straightforward only. Okay.
It's okay, sir. Start with activity.
Okay. Okay. Then okay. How many configurations are possible for partitioning 100 data points into 10 clusters? If these clusters are allowed to be empty. So I think yeah, based by in stats or probability, you would have learned like if you have 10 boxes, a 10 cluster. So it is simply saying that you have 10 clusters and you have 100 data points. So obviously combination will be 10 to the power 100, because every point would have the like 10 chances. I mean, every data point had 10 options. So 10 into 10 into 10, 10 to the power 100. I think that would be the correct answer here. Okay, let's move to the another question. Okay, so okay, yeah, a cluster will be good if the data points in the cluster are far apart. No, see, the main use of cluster is to create a set of homogeneous points. Okay, I mean maybe in simple words, it's like k-means job is to form a group, and obviously you divide group based on something, no, I mean based on the similarity only, no. So that so any options related to this will be the correct answer. The points are in the cluster are far apart. No, the points in the cluster are close to mean of the center. Yeah, that's true. And the points in the cluster are homogeneous. Okay, so these two things are true. Okay. Yeah. Let's move to this third one. I think if Z1 to Zn represent the cluster assigned to the data point x1, xn respectively, then which of the following would represent the mean of cluster K? So which one do you think? I mean, obviously, this one is, I think, yeah, last one. I think it's a straightforward active formula which sir has derived. I think yes, sir has also written it. So it is nothing but it is showing that one. So mean of every cluster. Okay, I mean the mean sum of distance of every cluster and the like how many clusters you have. I mean how many data points you have in each cluster. So that will calculate the mean. Okay, I think yeah, x1 plus x2 plus something xn upon n. So this once you will, I mean explained it, you will come to that place. Okay, if z1 to zn represent the cluster assigned to data points x1 x up to xn, the and mu k represent the mean of the cluster, then which of the following would be a good measure of goodness of partition? I think yeah, this is also like exactly it's just a game of, I think everything is exactly from the sir slides only, like sir has already shown this. Okay. So yeah, it's like a xi minus mu of zi. So here zi is denoting the cluster index. Okay. So I think yeah, that's all in week. I mean 1.1. Let's see if I'm just looking for some good questions. So if there would be some good question, we will I mean focus more at that place. Otherwise, even if you have some other question, I mean if you want me to explain any other question in detail, you can stop me at that place. Okay. Let's, okay, 3.2. Okay, it is okay. If time permits, I'll show something. I mean, okay. Let me just, or maybe I would have some other places where I can. Okay, here I have questions. Okay. Actually, I just got logged out. I don't know why. So, okay, here I have. Okay. Okay, here I think answer is also visible. Okay. Okay, that is also fine. Okay. Does K-mean always converge? Obviously, K-means will converge, but it doesn't guarantee that whether it's I mean local minima or global minima. Okay, I think yeah, already we discussed it. The solution produced by K-means algorithm is always optimal. That is false. I mean, obviously that is not true. Okay, and which of the following is true, is or true or are true? Okay, so K-means algorithm cannot automatically determine the value of K. So obviously we discussed it. And finding optimal cluster in is an NP hard problem. So I mean, yeah, that also I think many times professor has talked about it. So because like why it is NP hard problem? Can anyone say?
So because there is no polynomial time equation.
Right. Okay. If an iteration, if
So
in
can
an
you please
iteration,
repeat why
Optimum.
it is a NP hard problem, sir?
see, NP hard, yeah, someone was saying. Yeah.
The hard problem means that it is very difficult to find the optimal cluster.
Yeah.
The possibilities are like k to the power
Yes.
n, right? That many number of particles can happen. So there's no optimal solution. It's exponential.
Right.
And
Okay. Thank you.
Okay. Non NP hard means non-deterministic polynomial type. Okay.
Okay,
So
sir.
that.
Thank you, sir. Thank you.
If an iteration t, if in an iteration ti, the distance of data point from the means of its cluster, currently assigned cluster is the least as compared to its distance from the means of the other cluster, we do not change the cluster assigned to this data point in this cluster. Okay. So, what do you think? I mean, okay, actually, answer is directly visible. That's why I think yeah. So here, let's go to the question again. If in an iteration t, I the distance of data point from the mean of currently assigned cluster is the least compared to its distance from the mean of the other cluster. We do not change the cluster assigned to the data point in this iteration. Okay, right? That is true. In this context, which of the following is true? I mean, obviously you are able to see the answer that this one will be. So why do you think? I mean, can anyone explain this one? Explain this question? At least give the clear reason about this.
So
so
this
in the
could be
current
because the
iteration, it
mean.
might change.
Just go one by one. That okay.
Yeah, I was saying in the current iteration, it might not be that the cluster number might change, but in next iteration, it could happen that one of the cluster means changes and comes closer to the current x coordinate, this data point, and that might change the cluster number for that.
Exactly. Right. Yeah. Okay, let's move to the 3.3 part. Okay, okay. Okay, actually 1 hour is only left. Okay, we'll just discuss it quickly. Okay, consider a bunch of points x1 to xn, uh, where x belongs to RDA subspace. Which of the following would represent a point V, whose sum of square distances from the point x1 to x2 is the minimum? So I think yeah, this one. Obviously, it is the mean because this represents the mean of that all the points. Okay. So for data points x1 to xn partition configuration, z1, z2 are the mean of the cluster of the kth cluster. Which of the following represent the objective function of Lloyd's algorithm? So yeah, this one. I think all these questions are straightforward. If the value of objective function is strictly reduced, it indicates that partition cannot repeat or partition may repeat. What do you think?
Cannot repeat.
Cannot repeat.
Cannot repeat. Okay. Okay, cannot. So I mean, whoever has given the answer earlier, some other person. Can you explain? Any other person? Can you explain? Can you guys explain why and what does it mean? Yeah. Anyone would like to give it a try? Anyone just give.
So
Yeah.
the partitions will not repeat because every time the objective function is reducing, the points that are assigned to one cluster shifts to another cluster. So the possibility that the partition that was earlier will form again is zero because the function of our objective function is strictly reducing.
Right, right. So what this question is saying that I mean if you let's say if some point is assigned in group one and some point is assigned in group two and some point is assigned in group three. So in the next iteration, if our objective function is decreasing, that simply means that I mean reassignment will happen, and then the same party in that the same partition can't repeat. Okay, you can't get the same thing again. Okay. Uh, so fourth question says that choose a correct statement. There is a finite number of partition configurations. Oh yeah, I think yeah that is what professor has proved in the last lesson. Right?
Sir, whenever the partition will not repeat, the iteration, the
Yeah.
algorithm will terminate, right?
When the partition will not repeat. See, when partition will repeat, then only algorithm will terminate. Partition. Yeah.
No,
See.
sir. It is like since the partition will not repeat, and there are only limited number of partitions, that it means that the algorithm will converge. That is what Professor I think said in the.
Okay. 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 Just repeat. I think maybe some wording, rewording confusion is there. Okay. So what you are saying?
I'm saying that since we know that the objective function is decreasing, that means that the partition will not repeat itself, right? And
Right.
also we know that there are limited number of partitions possible, which is like
Right.
k to the power n, right? So that
Right.
means that at some point of time, all the partitions will be exhausted, so the algorithm will converge.
Right.
Right? Yeah.
Yeah. So
Yes, sir. When
here I
all
think
the points are happy with their mean, the algorithm will end, right?
right. Yeah, that is true. So see what is happening now, and I think what you guys are seeing. So see, once you reach at the minimum, I mean the minimum point of your objective function. No, I mean yeah, minimum value of your objective function. Then even if you, I mean, if you do something, I mean your partition won't change. Okay, I mean the whatever the like any point is assigned to like whatever group. No, that won't change. Okay, I think everyone is clear about it, or
Yes, sir. So
everyone is
there
silent.
will not
Yeah,
be any reassignment if all the points are
yeah.
happy.
Reassignment won't happen. Okay, so yeah, that's true. Okay, there is a finite partition configuration. Okay, okay. Let's go to the next set of questions. Okay, activity 3.4. So I think yeah, wording confusion is there. Okay, okay. If mu1 and mu2 are the means of two clusters in k-means, then for all data points setting in C1, the so obviously if those data points are in C1, then mu1 will be closer to the mu2. And for a big cluster, its Bernoulli region will form for intersection of k minus 1 hop space. I think your professor is shown into 3D spaces. I think yeah. Points were in I mean 3 dimension or 2 dimension only. I don't. I think Professor is showing
Uh,
3 dimension.
No, two
Yeah.
dimension, but three spaces.
Oh, okay, okay, okay. 2 dimension and three groups. Okay, three clusters were there. Yeah, I remember. Okay. Choose the correct statements. So K-means can efficiently cluster data points that are not linearly separable. So no, that's not true. So data set should be linearly separable. Okay. And if it is not linearly separable, then you have to use I mean kernel K-means. Okay. Which of the following is true with respect to optimality of clusters? Okay. Getting yeah, and optimal cluster is an NP-hard problem. So no techniques exist that can guarantee optimal solutions. Okay, to obtain good cluster, how should the initial means of cluster be? Obviously, means should be as far as possible.
1 second, sir. Linear separable means it is homogeneous. Is that right, sir?
No, I won't say that. See, homogeneous. Uh, what can I say?
Same kind of data in one group.
Similar kind of data in one group. That means homogeneous. So what we are saying, no, I mean, let's say even if some data set is in a 4D, okay, one group is here, one group is here, okay, one group is here, okay, another group is here. So you can easily separate them based on just the lines, okay, just by using lines. So
Okay.
these are linear separables. But when your data points are in like a circular shape or any other shape, okay, or maybe this uh, shape, okay, it is not linearly separable. You have to, your boundary should be I mean non-linear to separate the data, no?
Okay, sir.
You are seeing? So yeah,
Boundary. We mean boundary. Linear separable means.
yeah, yeah, linearly separate. Yeah,
So the K-means algorithm only distributes the points linearly, sir. So
right,
it will not make circular cluster.
right. Yeah, came okay, someone messaged something. Okay, I don't know. Okay, I would have got some message. Okay, K-mean plus plus initialize the clusters means obviously it's a probabilistic model and it does it in a iterative fashion. Definitely, I will recommend you to go to the I mean the previous session which I had taken. So where we have discussed like in what cases like K-mean plus plus can also not work well. I mean if you take it like instead of probabilistic model, if you take the directly the distance only. Okay. Okay. During different iteration of the initialization steps, K-mean plus plus assigns highest probability to the point to those points to be chosen as a clusters means. Okay. So I mean, obviously, it assigns the highest point, highest probability to those points, which is I mean more far from the I mean, which is very far from the I mean your old cluster mean. Okay. And yeah, due to smart initialization of
Please
cluster.
explain this question three's activity.
Okay,
Question and
so
short question.
here I would say it is just a game of words. Okay, simply if you see, I mean, what question is trying to say. See, let's say, okay, I'll just give you. See, what is our goal in K-means clustering? I mean, K-mean plus plus. Our goal is to take those points in K-means. Our goal is to take those points as cluster centers, which is, I mean, far apart from the, which is far from your previous cluster center. Okay, let's say this was your cluster center one.
Okay.
Okay, then you will take those point as the cluster center two, which is
Very far.
far from here, very far from here.
Yes,
Okay,
sir. I'm
so
clear up to
let's
this
say
step, sir.
yeah. So let's say C1 is there, C2 is there. Now let's say we have one more point. Okay, this one from C1 it is like 3, C2 it is 4.
Yes,
So
sir.
which one will you see? Which one will you consider
C1, sir.
C1? Because this is the closest mean, and based on the its distance, it you will decide like which one is the
Yes,
farthest.
sir.
Okay,
But
yeah,
if we
that's
see in the score perspective, then it will be the minimum one, no, sir. We are choosing the minimum score only, no, sir.
yeah.
Is
So
it
yeah,
correct to
this one
say?
will be the score for this point. Okay, for this point, this score will be 3. But let's say some point is here. So for this point, and it is far from here, like let's say 5. Okay, so here
Okay.
its score is 5. So which one will you choose? This one or this one is a C3?
For what? For C2, sir?
No, see what is happening. No, let's say you have to decide. You have to take 3 clusters. Okay,
Yes, yes, sir.
okay. You have these many points. Okay, so let's say I have already assumed that this is C1, this is C2. Okay,
Yes, sir.
okay. For this case, just assume it. Okay, so then here it is far from here like 3 points. It is from here 4 points. Okay, obviously this one I'm assuming 5, and this one obviously it will be much more than 5.
Yes,
Okay,
sir. 4 will
so
be determined by the probability, no, sir. In the
yeah,
probability
yeah.
method,
Yeah, so
normalization method.
yeah, yeah, I also I like in the last one only like we discussed like why
Yes,
only considering distance it won't work. I mean it won't help. But for now, let's assume that's a normal case where distance can work. Okay, or at least
yes, sir.
I mean yeah, yeah. Only the I mean so do not worry about their points density. I mean the group density and other things. Okay, do not bring those things into the picture
Okay, sir.
like which we were discussing in the previous week. So I mean previous session. So just take it like this. Okay, so I mean just to consider this question only. Okay, so
Yes, sir.
here
Yes.
I mean for this point the score is 3. Okay,
Hmm.
maybe 3 by something or I mean whatever is,
Okay,
or
okay,
at least
okay, sir.
proper. And for this point it will be 5.
Yes,
Okay,
sir.
5 point something, 5 by something. So I mean which one will be your C3? This one will be your C3, no? So I mean how you decided the closest cluster mean the distance of the point from the closest center cluster mean. So I mean for this it was 3, for this it was 5. Okay, and based
Okay,
on these values you decided that this one will be your next cluster. Okay,
okay, okay, sir.
see our ultimate goal is to get the more diverse points. Okay, I mean more diverse points, so that I mean it's good to I mean capture all the combinations. Okay, and if you
Okay,
take
okay,
the more diverse points, then yeah, it will be I mean you will be able to converge it quickly. I mean in a lesser number of steps.
okay, sir.
Yeah. Okay, let's move to activity question 3.6. Okay. Yeah. K-mean algorithm automatically determines the value of k as per the given data. Obviously, it's a false. Which of the following is correct with respect to the value of k? The value of k should neither be small nor be large. Obviously, in the last one also, like we discussed at the beginning only, like we discussed why k. I mean, why k value should not be a very large and why k value should not be very small. It should be optimal. Yeah, we took multiple examples like 100 and 5. Yeah. If objective function represents the value of objective function and t represents penalty, then the best value of k will be that for which objective function plus penalty should be minimum. Obviously, we add the penalty. We do not multiply it or subtract it or divide it. We add it. So, which of the following techniques is in fixing? Which of the following techniques help in fixing a suitable value of penalty? Obviously, yeah, archaic information criteria and Bayesian information criteria are the one like which help us to suit the to set the penalty value. And my elbow method is just a method to check the I mean what you say I mean to get the optimum number of k values. Okay,
Sir, could you please explain these two methods a little bit?
I mean that will be I mean again it will take a very long time and it's beyond our syllabus. That is what I can say. If you want I mean if you want to know about it, I mean obviously you can search it on Google. Okay, just think it like yeah these are the methods. I mean at least if you know the name, that is more than enough for our syllabus.
Sir, for now, can we just use the elbow method for simplicity if we like, if you want to use it, because inside the tutorial they have shown the elbow method.
Elbow method. Okay, okay, okay. So okay, I think last in the last one I gave you the examples of elbow method. I mean pro and cons of everything we discussed. It. I would definitely recommend you guys to see the previous lecture. Okay, I think in the previous lecture mainly we discussed these things only. Okay, so elbow method. Yeah, I'll just give you the brief summary. Okay, what happens in elbow method? No, when let's say every point, let's say k equal to 1, 2, 3, 4, 5. You have these uh, number of cluster centers. What will happen once you will go through once you will see at k equal to 1, this is the error you are getting. I mean sum of square error. Your objective function value, you remember, no, xi minus mu I square. Okay, xi minus mu z I square. Okay, So you are getting somewhere near to this, okay, or mean of square error, okay, mean of sum of square error, okay. So for k2 values you will get this one, k3 you will get this one, okay. So what happens here, no, and let's say if your data set is 5 and 5 dimension only, that will directly come like this. But let's say your data set is like 100 dimension, so what will happen, you will get the plot something like this. I mean, this is on, I mean, the best possible case. Obviously in ideal life, in real life you won't see shape of shape like this, okay. Actually, I do not want to discuss all these things like in what we have already discussed in the previous session. Just I'll give you the brief summary that, yeah, so wherever you see that slope changes rapidly, no, that is the point. It is good to take that point as a I mean, it is good to take that number of cluster as a optimal number, that number of cluster in your algorithm, okay. So here, I mean, in this case, you can take k equal to 3
But
for
sir,
your algorithm.
what if that rapid change in slope is not apparent?
Obviously, in most of the cases, you will see that this rapid changes in this. If you go in real world, no, you won't see that. I mean, you won't be able to visualize it properly. Okay, here this is possible only in those cases where it is. I mean, if your data set is like this, no, I mean, here you see, no, this type of shape. I mean, it's easily separable, no? I mean, then in those cases only you will see that, I mean, this type of rapid changes. Otherwise, you won't see this type of shape. Okay. So in those cases, what you do ideally do, you know, let's say you have 1,000 samples, then you just iterate through the each number of combination, like all combination. Like let's say from if you have 1,000 samples, then under root of 1,000, ideally what we do like 33. So we just iterate through the I mean all the k equal to 1 to 33 and see which one is giving you the lesser error. Okay,
Okay.
like this we do. I mean, definitely just I mean, I'm just trying to briefly tell about the like what we have discussed in the previous session. So I have discussed this in the previous session.
Okay.
So we take k from 1 to square root of n.
Yeah, this is the general practice we do. Okay, so I mean, see, I mean, here we are talking that elbow method will work, but in real life it doesn't work. I mean, in real life, I mean, it's good to visualize if you will able to see, and there can be multiple possible cases. What you will see, I mean, maybe here you see this change again, this change again, something like this. Okay, now you will be confused which one I should take, which one is the optimum cases. That also like in the it all these things depends on your data set. Okay, there can be cases like okay, and there can be cases like let's say at least you have some I mean fixed number of samples, no, at least let's say not fixed number of samples, not fixed number of dimensions, no, at least I mean some small amount of dimensions, then you will be able to see this. Otherwise, if your data set let's assume that your data set is I mean there were few cases where we are discussing, no, where it is very difficult to separate the data points, then in those cases, no, you won't see I mean this type of bend. Okay, then you will see like I mean it's like I mean obviously you won't be able to visualize this elbow. Okay, in those cases also like you will have to plot all the point. I mean you have to check all the k values, maybe from 1 to 100 or I mean whatever the values you have. Okay, and just see
Sir,
how much is score.
sir,
Yeah,
sir, there is one more method. Like it was
still how
like
to score
95%,
95%.
95% of the, yeah. So 95% of the value that should be in. I mean that is the
That is in the
perfect
PCA, no? That is in the PCA, no? You discuss that in PCA you cover, no? Like if you're, I mean, if you take those components, I mean, if you take number of components in such as much number of components so that you can cover 95%. I mean, of the
So
variance.
Sir,
so
so
is
I
there
want
not any way for like that here?
So here, as I told you, no, here only one way is there that I mean it works properly, or at least the way I mean, see, in real world, what we do, no, I mean, as I told you, if you want to try it, what we do is that here we usually let's say if you have 1,000 samples, no, I mean I'm taking them, so just take it a root of this these many things. Okay, if you have 1,000 features, then just take a root of it. It comes near to 33 point something. So you will just iterate from 1 to 33 k values and see which one is giving you the best result. Okay, this is what we do in real life. Okay, at least otherwise we have methods like this one is the one of the method elbow method. You have still hot score also. Okay.
But so k equal to 33 will obviously give the best result, no?
No, there is no cases like that. K equal 33 will give you the best result only.
So means like the higher the k, the better the value of the objective function, no?
So see, let's say, just take this example. Okay, here you have three sets. Okay, what do you think? I mean, if you are taking k equal to 3, okay, it's two. Okay, do not take 3 because
Sir,
since yeah,
sir, we have already discussed this in details in the last lecture.
yeah,
You
yeah,
have
that
asked
is
what case should we choose given 5, 20, 50.
right,
There
right,
is no
right.
point discussing all this again. The same thing.
That is what is happening currently in this session. So basically, I am also not able to explain everything in detail because like we have already all discussed all these points in the previous session. And again, whenever I'm trying to discuss, I'm just trying to compress it. And when I'm trying to compress it, I'm even I'm not feeling comfortable that I'm explaining it properly. Okay, so I would definitely recommend you guys to discuss. I mean, to watch the previous session. All these points, like whatever you are saying here, no, I mean exactly these things we have discussed in the previous session.
Okay, sir.
Okay.
Okay.
So yeah, I mean, just I'll give you since I have already plotted. So let's say here, okay, you have you have three groups, okay. But if you will take k equal to 4, do you think that k equal to 4 will help you here? I mean, if you it is your general assumption that once you will increase k, then obviously every time you will get better. I mean, better result. That is not true. There are multiple issues. I mean, overfitting is the one of the issues, and obviously. Running time, or I mean the amount of time it will take to amount of time it will take to converge it, no, I mean that will also increase. Okay, these are the two main criteria. Okay.
Okay.
Yeah. Okay, maybe yeah, let's discuss the practice question. Practice. Okay. Yeah, I thought that I'll be able to keep it, I mean separate from the, I mean keep it independent, but it is difficult to keep because a lot of things are we have discussed in maybe just understand like in the last session, like we give just 2 hours, precisely 2 hours to just discuss these concepts only, nothing else we discussed. So that's why I think here I'm not doing justice to I mean when I'm just explaining it again to those people like who had attended previous session,
Yes.
and here they are here just to learn something new. Okay.
Yes.
Okay. Okay. So, which of the following sequence is correct for K-means algorithm? Obviously, first we assign cluster center randomly. Then, once we do that, after we assign each data point to the nearest cluster. Okay. Yeah. So 5. Uh, okay. Okay. Just let me see. Okay. So here
Specify
one more
the
point is,
number of clusters.
yeah. Specify the number of cluster, then assign cluster randomly. And once you assign cluster randomly, then assign each data point to the nearest cluster center. And then what you do is that you assign, what you do is that
Recom-
you just, sorry, someone is saying something.
yeah, I was saying
Recompute,
recompute.
yeah, recompute center. Yeah, right. Again, then you recompute cluster centers and then again reassign each point to the nearest cluster mean. Okay, that's how it goes. Okay, I think it's a fairly simple. This one is also like a directly listed forward sentence. I mean, obviously the new mean will be, I mean, a new mean would have the lesser value. I mean, some of what do you say? I mean, the new centroid will be, I mean, obviously the value of new centroid will be the lesser than the older centroid. Okay. Uh, Third point, I think with these things, yeah, professor has already proved air lecture. If mu1 and mu2 are means of two cluster in K means, then the boundary between the two clusters means will be obviously perpendicular to the line joining the mu and mu2, and it will be at a point of like mu1 plus mu2 by 2. I mean the point like which bisects the two means. Okay, distance between which bisects that, I mean these space into the two half spaces. Okay, which is nothing but like mu1 plus mu2 by 2. Consider the following data points. Okay, assume k means is run on these point with k equal to which of the following are expected to the cluster means out of k means. I think last session also like I had drawn this figure. and we had done some discussions on this. Okay, let's see. Okay, so what do you think? What would be the answer here?
So second one.
Second one. Okay. What about others?
So the second one only, but I don't know why.
So
It should.
second
It
one
can be,
because
sir. It can be first one also because if we draw, if we separate like we did in the circular that is shown in the
Mm-hmm.
video. So
Mm-hmm.
it could be first one also because we
Okay.
can separate blue line and yellow line in between.
It won't be the first
Mm.
one. If you see, like in the first one, the cluster mean will be around the center point, right, which is around 3. The x coordinate will be 3. And if you check the purple line itself, right, the difference, like the first point is at a coordinate x coordinate 1, the mean is at x coordinate 3, so distance is 2. But the points on the yellow line are at distance about 1.5. So some points on the yellow line will also be form a part of the cluster.
yeah,
Okay.
exactly.
Okay. So
Sir,
first
Otherwise,
of all,
there would be
sir,
some
sir, if
points
we
that
go
would be
by
below the yellow line, and there would be points that are above the purple line. But then there would be a chance that the points that are at the extreme ends of both lines will actually be far away. So it could be possible that the point, the yellow lines, the cluster center of yellow line, might connect to the purple line.
okay, I'll give my comments here. So see, there are so I mean, first of all, this question also like not intentionally, but we had taken this example in last session where we said that there are multiple factors which can affect these type of cases. Okay, maybe in different cases. Maybe yesterday, day before yesterday we were discussing about the case like based on the initial point, initial centroids, result can change. Okay, so that this point we were conveying in the last session, and based on that we were talking about this. We had taken this example. Okay, but I didn't know like this is also in our practice question. So here, first of all, both answer can be correct. Okay, it completely depends on the three factors. Okay, I'll tell you here. Okay, maybe if time permits, I'll write code for this. Okay, and we will see in the real time what happens. Okay, so there are three factors here. Okay, see, first factor is that the distance between these 2 points. Okay, between two samples, distance between these. Okay, let's say y. Okay, so yeah. Okay, directly this is y. Let's say x is the distance between two data points, and y the distance between these two parallel lines. Okay, so it depends on y, it depends on x, and also it depends on the based on our initial centroids. Okay, if we will take initial centroids anything other than these 2 points, no. Okay, the center of these two lines, we
Yes,
will
sir.
get this result, we will get this one. Okay, the second one. But if we take the our initial centroid as these 2 points, then we will get this shape, this type of clustering. Okay, maybe, yeah.
So actually, you will never get the first one because you see the distance between the center and the extreme points on the line,
Okay,
right? That
I'll
is
show you. Okay, maybe I'll. Okay, we will check. Okay,
Possible
we
no, no.
will
because
check.
I understood
Yeah.
your
the
point,
point
sir.
on the
Just see, like if you take the purple line itself, the center will be at coordinate 3.3 comma 3.5, right?
Okay, yeah, right.
Right,
For
and
this one,
for the purple line,
right, 3 3.5.
right, and the extreme points are at 1 comma 3.5 and 5 comma 3.5.
Okay, 3 2. Okay, the extreme points are here.
Yeah, so 5
5
comma
comma.
3.5 and 1 comma
Right,
3.5, right? The distance between the center and the extreme is 2 units.
right.
But if you take a point such as like 3 comma 2, right, the distance between 3 comma 2 and 3 comma 3.5, that is just 1.5.
Which one? Sorry, just I didn't. Okay,
The
I'll keep this question at the end. We will discuss this question in the end. I'll show you. Okay, do not worry.
So I'm
If
just
time permits,
saying that
yeah.
the distance on the purple line itself is much more than the distance between the two lines. So the two clusters will actually I don't think you will be able to achieve this result.
Okay. So you are saying, okay, this result we won't be able to reach. Okay. I'll show you. Maybe yeah. It's better to see it via some. Maybe I'll write the code actually. Okay.
Sure.
Then we will see. Okay.
But if we are seeing that the cluster centers are lying on the line, the points that are not lying on the line would have to actually cover a greater distance even for the extreme points.
Okay. Basically, okay. Let's keep it at the end. Okay. I think yeah, that it would be interesting to even see also, even for me also. Like, okay. We will see. Okay. As I told you, like it completely depends. See, as I told you, one thing is for sure. I mean, there are three factors which will play the role here. Okay, your distance between these 2 points, distance between these lines, and number of data points. Okay, number of data points also. Like I think, yeah, I didn't say about this. No, number of data points. Also, number of data points. Okay, or maybe the you can say that, yeah, length of this line. Okay, length of this line, you can say, instead of number of data points, you can say length of this line, distance between these two lines, and distance between these 2 points. Okay, I will see. Okay. Leave it for now. Okay, we can write code. Okay, in the initialization step of k-mean plus plus, the square distance from the closest mean for 5 points are these things. Okay, in the construct, which of the following are true? Okay, obviously x3 will be chosen with the highest probability. Okay, because it has the highest distance, but again, this is not sure that, I mean, definitely it will be chosen. Okay, with respect to Lloyd's algorithm, choose the correct statements. Obviously, the participant configuration cannot repeat themselves. Obviously, an objective function after making the reassignment strictly reduces. I think, yeah, these are the points like which you would have also seen. And for 1,000 data points out of k equal to 1, 10, and 100, which value of k is likely to result the maximum value of the objective function? Obviously, k equal to 1, because if you see, ultimately objective function is nothing but the distances. No, let's say you have, okay, and if your k equal to 1, then you are what you are doing, you are keeping it into one single cluster, and here this is your k, so you have to sum all these lengths. No, so obviously it will be something, let's say if it is 10, then what about this, when you have these points, and these points, and now you have to calculate distance between here, from here to here. No, just these distances, some of these distances. So obviously it will be little lower than this one. So that's why k equal to, I mean, when you have a k equal to 1, this will give you the highest distance. I mean, the maximum, maximum distance value, maximum objective function value. Okay.
Sir,
Yeah.
sir, on question 5, why can't we say it is definitely be chosen?
Where?
This x3
Okay.
will be chosen with highest probability. That is correct, but we are
Uh,
not sure whether this will definitely be chosen. But this
yeah.
is the farthest, right?
This is okay. So again, in the last one, do you remember that questions? I mean, where we were discussing about 2D cases, like where we had two data. I mean, this was the data set. Like here, we have a good amount of. I mean, see, it depends. Like when your data set size, I mean, the group size is different.
Okay, yeah,
Okay,
I got it.
and that's it. Yeah,
Yes. So the
Uh,
way it will chosen, it depends.
yeah,
So for that we have to calculate all the distance and score them and then.
yeah.
Okay, understood.
Okay. So I think, yeah, this one, for k 100 data points, if k equal to 100, what will be the value of objective function? So obviously 100 data points. This one also, I think, yeah, in the last session we discussed. Okay, so if you have 100 data points and you have taken 100 cluster also, which simply means that every cluster has just 1 point, right?
Sir, it can't be deterministic manner. It's probably
Sorry. Hello. Someone was saying something. Okay, so I think he was saying that it is not a deterministic metal, it is a probabilistic metal. Obviously, yeah, it is a probabilistic metal. So in the last time we were discussing why it should be a probabilistic model only. Why we can't keep it a deterministic just by keeping the distance. So that we were discussing that if we keep it a deterministic, then if the size of different cluster, I mean size of clusters are different, and or the density of clusters are different, then that won't work well. Deterministic method won't work well. Okay, so that's why we are using this probabilistic method. And probabilistic method is all obviously means that it's a probability only. Okay, that doesn't guarantee. Okay, choose the correct statements. One initialization might get stuck in local minima, while another may lead to global minima also. Obviously, it can happen. Okay, where if you just by taking some initialization, you may stuck to the local minimum also. Like here in this case only, like as for now, just take it like if I'm claiming that if you take this as initialization, no, you may come up with this figure. Okay, I mean with this say, but if you take any other point as initial points, initial centroids, then you will come up with this shape. Okay. Okay. So yeah, that's the
If
thing.
k is equal to n, then we will get the first one, sir.
For k equal to one,
The image. No, no, the previous one, sir. The above
which one?
image we will get, sir. If five clusters is equal to five data points, that means we are assigning each data point into one clusters.
Yeah,
Then we might get this image, sir.
this image simply means that you are so see here different clusters are representing different cluster. So here this cluster is representing this cluster. Okay, and this one is representing another cluster. Okay, the
Yes,
different
yes.
so here we just have two clusters. Okay, so what you are saying you will
Then,
take five
then
clusters.
now we have two clusters now, and if we have only two data points instead of these many data points,
Oh,
if
okay,
we
okay,
have only two data points, then the clusters the image will be like this only. No, I'm asking, sir.
okay. uh, if you have just two data points, okay,
Yeah,
then and how many clusters?
two, sir.
Two. Okay, okay, yeah, then this will be the shape.
Yes, sir. Okay, sir.
uh, okay, yeah. Okay, so yeah, obviously if you see, I mean if your cake values is 100 and you have just 100 samples, then in every cluster you would have just 1 point, and obviously if 1 point is there, then that will be the only mean also. Okay, so if this is the point, I mean this is your xi also, and this is mu I also, then the obviously difference between xi and mu I will be 0, right? Yeah, so that's how it is there. Okay, okay, I think yeah, that's one also, like we say that. Okay, one initializer might get stuck in local minima, and while another may lead to global minima. Okay, the initialization of cluster center may affect the number of iteration k-means takes to convert. Obviously it affects the number of iteration. Okay, that's why we that's why in if you see, that's why we came in plus plus came into the picture. No, it also it doesn't I mean obviously it helps you to get better results also, and also it takes a little lesser time. Okay, it may at least it may take lesser or equal to time than your came in algorithm. Okay, because your initial centers are cluster centers are better if you came in plus plus algorithm. Okay, I think any doubt or any confusion here? Anyone would like to say anything? At least speak, yeah. Uh,
Yes, sir. We got those points. One thing I
uh,
wanted to know, since a lot of courses, a lot of things that are being discussed in MLT, is giving us a idea about how these algorithms actually are, and we are not actually diving into the very nuance of how the
yeah,
how the algorithm are. Like some, there are some parts that are we are still considering that are out of our course. So will it be same when we are giving an exam or giving the quiz or end term, or do we have to work on this, or the level of questions will be different than we are getting into our practice and grade assignments? Because this is somehow like MLT is easier than MLF, because MLF was more maths. Like this is a low more algorithmic. We can say that MLF was more difficult than MLT. So yeah, this is what I want to know. What would be
So
the level of
see,
question?
first of all, I'll tell you. See, in MLT, see the main problem and other things also. Like see, MLF also you had lot of concepts, and MLT also like you have lot of. See, K-means is a easy topic. Okay, that I would say, but do not think that I mean the questions completely depends like on the instructor's mood and like what he wants to do at that moment of time. Okay.
Okay, sir.
Okay. If you think that, I mean, if your questions can be easy only or question can't be created, that's not the thing. Okay. It completely depends on the at the moment. If instructor thinks, I mean, if he is planning to create some good level of questions, then definitely there are a lot of things we can do here in this topic also. Like there are a lot of things which we can do. I mean, just by using these concepts only, like whatever the concepts we told, just by using this concept only, it completely depends on the instructor's mood. Okay, or at the what he wants to do. Okay, if he is planning to create some difficult question, then yeah, there are a lot of things by which we can create difficult questions here also. Okay.
So one question here.
So yeah, yeah,
In K means like you calculate the distance, right, between the 2 points. So
right.
how do we? I mean, which formula we use? The normal formula we use, or like when we
Euclidean
given
distance, yeah, Euclidean.
Euclidean. Now, sir, if it is a
Yeah.
Manhattan case, Manhattan maybe right, they can give right
Hmm.
Manhattan case also they can give.
Yeah.
How do we find? I mean, I don't know what is Manhattan, but I just heard the term like that.
Okay,
How does that
so
work?
Manhattan is nothing but just the absolute distance. Okay, for example, okay, my screen is visible, no?
Yes, sir. Very
Yes.
much.
Yeah, let's say you have these 3 points. Okay, and this one is 3, this one is 4, this one is 5. Okay, and I this one is A, this is one is B, this one is C. So what is the distance between A and C?
5.
Okay, between A and C, you are saying the distance is 5. Okay, or okay, maybe I should not draw this line. Okay, take it like this. Okay, so that at least A point. This is 3. This is 4. 5. So obviously, if I ask you the distance between A and C is, you said 5. Okay, this is nothing but this is Euclidean distance.
Okay. Okay.
Okay, but if you ask the Manhattan distance, no, the Manhattan will say that this is 3 plus 4, this is 7. Okay, basically Manhattan calculates the absolute sum and that should be the perpendicular distance only. Okay, according to Manhattan, it's a 7.
Okay.
Okay, yeah,
Okay.
that's the difference between Manhattan and Euclidean. Euclidean can simply calculate the shortest distance. Manhattan calculates the this one absolute sum of the like all the perpendicular, all absolute sum of all the perpendicular lines. Okay, like this. It goes perpendicular. Okay, like this only. Just you said this, no? Just take it example. Just take this example. Okay, here we are talking about this Manhattan distance. There are other distance method also. Okay, let's say I created the question where I will tell you that yeah, use this distance method to solve this one, to do the calculation. So what would you see? I mean the same topic, same concept. Just by changing the distance method, every calculation changes and the question's difficulty change. Okay, if I'm taking Manhattan distance, then that is definitely simple question. But there are other difference. Hamming distances are there. Okay, and some other distance methods are also there. Okay, obviously we won't do that. I mean, at least for this, at least this term, we are not going to use at least Hamming distances and other distance. Maximum we can move like a Euclidean or Manhattan because it's easy to calculate. Okay, okay.
Thanks,
But
sir.
you see, yeah. So, but you see, no. I mean, difficulty level depends on us. Paper's difficulty level completely depends on us. Okay, what we want to do. Okay.
Sir,
Yeah.
suppose in the above picture A, B, C, there is another data point D in between A and C.
Okay.
And that will provide, like, if we go from A to C through D, so the
Hmm.
Manhattan distance again will change. Like,
Okay. Okay.
that
Yeah.
may
A,
provide
B, C, and where you are saying the D?
somewhere in between. Yeah, they are only no, in between, like, what can I say?
Okay.
On top of D.
Anywhere.
Yeah,
Okay. Okay.
yeah.
Let's say here only.
Yes,
Okay.
yes, yeah.
So
Yeah.
see, for any point, if D lies in this line, no,
Mm-hmm.
then what would be the method to go here? You will go here,
Mm-hmm.
and then here.
Okay, the
It is
smallest
ultimately
one. Okay.
no, not the smallest one. The both will give you the same answer only. See, ultimately, what is this? This plus this is nothing but
Okay,
this only, no?
understood,
Yeah.
Okay, yeah.
Okay.
Okay.
B
So
point is just
just taking one thing. I mean, this is a like picture example you have shown here. So when we exams we see, so they give support data points. They give suppose three,
yeah,
3,5, 7, 8,8. Then
right, right, right.
how to approach that way, sir?
See, for all these type of questions, at least for K-means algorithm, what I would suggest, first of all, just visualize it. Directly, you will be able to get the answer. Okay, there are high chances that, if you visualize it, no, it will be very easy to get the answer. Okay, for your question's answer, like let's say you have 0.22 and 33, right? And for this distance, you will calculate like something like 1 comma 1, right? Right or not?
Yes, sir. Yes, sir. Sorry, I was forgot to
Yeah.
unmute, sir. Yeah.
Okay, okay. So 2 is there, 3 is there. So what do you think? Here you have distance 1, there you have distance 1. So which is nothing but sum of 1 plus 1, 2 only. Okay, and this one is nothing but also 1 only, no?
Root 2, sir.
Okay, yeah, sorry, root 2. Right, 1, 1, root 2. Okay, 3 minus 2, 1, 2 is or 3 minus 2 square. Okay, but for this, I think the whatever you will subtract, no, 3 minus 2, 1, 1, 3 minus 2, 1. Okay, okay, and just sum it. This will be your Manhattan distance. Okay, did you got my point?
Yeah, I got this one.
And
Thank
for
you.
this distance, Euclideans, yeah, x2 minus x1 whole square plus y2 minus y1 whole square. Okay, so I think, yeah, that's all about, I think, 10th question number 10 is still left. Okay, outliers are data point that deviate significantly from the rest of the data points. Knowing the way Lloyd's algorithm works, do you think it is sensitive to outliers? What do you think? First of all, are you guys aware about the outliers?
Yes,
I
sir.
guess, sir. Yeah.
Outliers. Okay. So yeah, outliers are any point. That is that is exceptional case. Okay. So it is saying that whether outliers will affect your clustering or not. So yeah, obviously it is going to affect your cluster. Let's say you have one group here and here. Here and here and there, and one point somewhere near to here. Obviously, it is going to affect it. And this is one of the biggest issue of the K-means algorithm. It is very sensitive to outliers. Okay. So if your data set has a lot of outliers, there are significant amount of outliers, then definitely, if you want your K-means to work well, just ignore those outliers. Okay. Because just see, if I consider this outlier, if I remove this one, no, this point, outliers means obviously it is minimum in number of cases, and it is minimum in numbers, and obviously it is behaving not as usual and not like other points. Okay, so it's better to ignore them. Okay, so this is also like in MLP, or at least in real life, you should try these things. Okay, definitely, when you if you are applying clustering algorithm, no, definitely first check if you have enough if you have outliers, and if you have outliers, no, just try to ignore it. Okay, it will improve your result, that's for sure. Okay.
But so then, say for example, we have 4D data,
Okay.
four-dimensional data. Then, sir, how will we detect outliers? Here,
Okay.
here we have
Okay.
2D.
Okay. Just, yeah. So you plotted here, so that's why you were able to see. Let's say you have column age. Okay. When you so you have to go feature by feature. Okay. By data point by age. Okay. Marks also there. Okay. Or anything, maybe age, marks, weight. What do you think by outlier? So age somewhere between 15 to, let's say, assume this class age only. Okay. let's assume that this class is between 15 to 30. Okay, for example. Okay, and if someone guy is there like whose age is 25, so how would you get to know about it? Obviously, if you will have to plus see the every columns, minimum value, maximum value. Obviously, you can draw the box plot. Okay, by that you can see that what is the outlier, or maybe just see the range of the columns. Okay, mean values of column. Okay, just see the mean value. Okay, let's for example, age mean value is coming somewhere near to 25. So obviously, plus 2 sigma minus 2 sigma, that will cover the 99.9%. Whatever is going more than or less than this, that will be outlier. So 85 will be outlier, or maybe 2 or 3 years age, that will be outlier. Getting my point?
Yes, sir.
So before applying k-means, just do that. Okay.
So we can find outlier for each and every feature.
Right. First, remove that outliers. Okay, or even if you ignore that, no, if you normalize the data set, no, okay, it will keep, it will consider that. I mean, obviously, it will bring that between 0 to 1, but still, it's better to remove the. I mean, if you have outliers, remove those outliers, and then normalize the data set, and then apply k-means algorithm. This is we do in real life. Okay. All right. Okay, since we have, I think, okay, we don't have enough time. Okay, I'll try to write the code. Maybe let's see. I think maybe in next 10 to 15 minutes. Uh, what is there? Okay. Yeah, someone is saying something. Yeah, Prasant.
So in K-means plus plus algorithm, to find a new mean, we are using a probabilistic method.
Yeah.
So why are we not using a deterministic method? So professor
Okay.
explained it in the lecture, but I'm not.
Yeah. Okay. So last session we were saying I mean, obviously I will again ask you to refer the last previous session. So see what happens. No, when you go with the deterministic model, no. So which simply means that just take the distance only as a criteria, right? So deterministic method means no, simply take the any criteria which is fixed. Okay. For example, let's say in our cases we had no one option. No, we can take distances only. No, I mean because we are saying that it is proportional to distance, right? Or I should explain more.
Yes, sir.
Yeah. So see, probabilistic and deterministic method, but there should be some fixed value. I mean, just based on fixed score, we will do that. Okay, or just based on some deterministic value, we will do that. And probabilistic simply means that. Yeah, sorry.
So we can just assign the next mean to the data point which has the highest score.
Yeah. Okay. So in that case, just see this example. And here you have, okay, maybe some little more closer. Okay. So what will happen? I mean, if you when you will start determining this one, so your this one will be your cluster 1, and this will be your cluster 2. Okay, and once you will start, like this one only, you know. Are you agree with me here?
Yes, sir.
Okay, and obviously let's assume that this distance is a little lesser. Okay, or maybe at least this point is so long. Okay, something like this. There can be the data set like this, no? So what will happen? So I mean, what your algorithm will do? It will create one cluster here and another cluster here. Okay, if distance is the only method. I mean, if you are using if you are just using distance only. Okay, which is not true, which is not a good result, no? At least in your this particular case, it is not giving you the best result. So in brief, I will say you this, that if your data set, I mean cluster size is different, I mean the group size is different, or if your density, okay, let's say in this one you have very, I mean maybe group size is, I mean it also depends on density, no, like how many numbers of this. So if there is a high density in one group and there is a lower density in other group, okay, this will also affect. So in these two type of cases, if you will see, no, deterministic method won't give you the good result. Okay, in normal cases, yeah, obviously distance method will give you the good result. But if your, I mean if your cluster size is different, and yeah, if your density of groups are different, no, then distance method may not give you the best result. Okay, got my point?
Yes, yes. Also, professor was talking about some guarantee.
Yeah, obviously, no one is giving you any guarantee here. No method can, okay, no method is giving you any guarantee. Okay, even with the k-means plus plus also, like in there is no guarantee that you are getting the best solution. Okay, you are getting the best groups. Okay, so that's the thing. It is just that, I mean, something is better than some other person. Okay, if I say it like k-mean plus plus is better than k-means. K-mean plus plus with a deterministic model will be, I mean, k-mean plus plus. Let's assume okay, take it. K-mean deterministic model. Let's say let's assume that in k-means you have deterministic method to choose the initial point. So k-mean deterministic will be better than k-means, and k-mean probabilistic will be better than k-mean yeah, k-mean plus plus deterministic method. Okay, I think I just missed the one word. Again, I'll repeat it. K-mean plus plus with deterministic method will be better than k-means, and k-mean plus plus method with probabilistic k-mean plus plus with probabilistic method will be better than k-mean plus plus deterministic. Okay, so that's why, I mean, in k-means plus plus we usually k-means plus plus we use probabilistic method, because there are few cases where a deterministic method can't give you the best, I mean, can't give you the better result. Okay, or at least the equal result also it won't be able to give you. Okay, especially the cases I discussed, like when your cluster size are different, when your cluster density is different. Okay, in those cases. Okay.
Yes, sir.
Okay, okay. Okay, I think someone is saying okay. You can come up with a scenario where obviously, which where the algorithm might not work anytime you run it. Okay, on the other hand, adding an element of randomness means that you cannot come up with the scenario that would fail always. Yeah. Okay, maybe, yeah, I think, yeah. What is the, let me see the figure first. I'll try to write for this one. Okay, basically 2 lines between right?
So in graded assignment question 1, I think they should have put a less than or equal to or a greater than equal to in one place. So here means like without giving the answer, like there should be one less than or equal to relation here. Means instead of strict inequality,
Okay, is it okay if I check it later? I mean, because like I need to check. Okay, because I want to discuss this one. I mean, this code part. Okay, or otherwise, okay, let me see. What would be the correct relations among the following three quantities? Okay, ut plus 1, where okay, see, what we assume, no, I mean, see, it will be like, I was also talking, no, in one of the questions that there can be, I mean, once you are getting the equal to values, no, then it simply means that, I mean, obviously reassignment is not happening. But if you are assuming that your algorithm, you are checking up to that value, no, then you can put equal to sign.
okay.
Okay. Yeah, if you are checking, I mean, if you are, I mean, cross checking, maybe just by, like, let's say on TS iteration you got the value, and you obviously you would try at t plus 1, then only you will see that, I mean, yeah, the values are now same. Okay,
Okay.
but
Okay.
what we usually say that if you t plus 1 is same, no, then reassignment is not happening.
Okay. So here we have to means like just understand that convergence is not.
Yeah,
And ignore the
yeah,
equal to sign.
yeah, sorry.
Ignore the equal to sign.
Right, 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 right. Okay, let me see this one. I think, okay, we plot it. Okay, yeah, linear space using linear space we will do it. Okay, let me connect it. Okay, so numpy, maybe matplotlib also like we should import matplot. Or yeah, k-means algorithm. Yeah, that also we should import. So for those who are new to, Python, at least yeah. So at least yeah, whoever is not aware about this k-means algorithm. This sklearn library. So sklearn is a library. Whatever you are doing here in MLT, no, sklearn library already has those packages or those modules. Okay. So let's say whatever the code you would have seen in the MLT programming assignment, no. Once I write k-means, no, I just imported it from sklearn.cluster. Sklearn library is there, and in this library you have the module cluster module. From there, I imported this k-means method. Okay, once I'll just directly use this, no, would not have to write all those codes. Okay, let's say line one is there, no, line one. Which one? Okay, this.
Sir, what if we were to not use some library? Then what would happen then, sir? The code would be.
Okay, then you have to, instead of this, you have to write all the codes like how k-means algorithm works, no, that mathematical calculation. Instead of this one line, that is actually here also. If you see this library, no, they have already written that code. Okay,
Okay.
behind this library, if you will search, they have written that code. It is just that now again, why to write those codes again and again? That's why I directly imported this library. This library is this module.
Okay, sir.
Okay. So in MLT, basically you learn like how these libraries work. Okay, what is the code behind this library? And yeah, here since again, once you write that code, why to write again and again? So that's why these libraries are made. Okay.
Okay, sir.
Okay. Maybe the points between, what was the center? 3.5, no? Okay. Yeah, maybe np.array. Okay. Let's say, so these are the points we have. How many points we have? Okay, between 1 to 5, no? Okay. Let's take it 1 to 6 then. Okay, that is closed. And yeah. Similarly, L2. And this one, I think this, what is the center? 2. I think, yeah. Now you have 2 lines. Okay. Okay. Okay, which one? Where I missed?
Sir, first you have to run the above code, import number.
Okay. Sorry. I missed to run this. No. Okay. Yeah. Let's say just tag this to make our data set. Vertical state. Okay. L1 comma L2. Okay. Why it is giving me the error? Okay. This is why you are using vertical. So then I think, yeah. All right. Maybe centroids we have to. Okay. Okay. Let's say centroid 1. Give it as a 1 2. Okay. And we'll give centroid 2 as a 2, 3, 4 now. Okay. Okay. Once we have done it, maybe okay, here only let's write. Clusters. Okay, write the full only. Number of clusters are 2 now. Then okay, import 6. Okay, so basically what you have to do here in this library, you have, since all the values you would have to write. Okay, for example, number of clusters we have taken it as a 2, then just write it 2. Write 2 here only. Okay, or maybe okay, yeah, write 2 and number of clusters only here. Okay, number of clusters equal to, okay, number of clusters we have already there. If we are writing here, then okay, basically either we can write here a number of clusters, or maybe if we are dividing, giving some values, then okay, init is there. Okay, initialization equal to obviously what is the cent we have written? Centroid. Okay, maybe yeah, just set the random state value. Maybe something any value, so that I mean just to produce consistent result, we are setting this random state value.
Sir, what is random state?
Random state is just a, I mean, we set it to some value, fixed value, so that I mean every time we get the same result. Okay, I mean whatever, if we set some random state value, no, so whatever assumption it is taking, no, our k means this I mean this module, it will take the same value again and again. Okay, whenever we will rerun it, no, it will take same values. Okay, sometime in some of the algorithm you see, no, I mean if you run it again, it gives you the different data. I mean it gives you the some different value, obviously very close to that old value, but it gives you the different value. Dot fit data. Okay, so by this we will be able to see the okay k means okay k means
Sir, in CENT, you are initializing some centroid, right?
see it, yeah, centroid. Okay, so yeah, we are, I mean, see, basically what k-means do, k-means take the initial centroid randomly, or if you are using k-means k-means plus plus, obviously it has its own ways to take the centroid. Okay, but intentionally I am taking centroid from my side, so that I can pick the centroid and see like what type of result we are getting. Okay.
So is this recorded session?
Yeah, sorry. Yeah, it is recorded. Okay.
Sir, here, just for clarity, I'm asking, L1 has got 5 points, no?
Yeah, 5 points. 1, 2, 3, 4, 5. I mean, yeah.
Sir,
1, 3 point. Yeah, sorry.
Sir, how would we increase the number of points in that?
So here I have written this one, no? I mean, for x in range of 1,6. So every time in this range, like 1, 3.5, 2, 3.5, 3. So if you want to increase the number of points, so obviously just increase this range. Okay. Instead of this 6, write something else.
No,
Okay.
sir, I wanted in 1 to 6 only, but the number of points should increase. Means like.
Okay. So yeah. So here I have not given that. So maybe for that you can write np.linspace. Okay, and there you can just put the points. Okay. Here, since I'm just trying to take this one only, no. For that, I think yeah, you can't do the just by using this code. Or maybe in the range, 1,6, you can also put comma and you can set the step size. Okay. Here also, like you just by putting comma, you can set that. Okay.
Okay, sir. Okay.
Okay. Let me see. Okay. Now we have these things. Okay. Let's separate it by seeing the cluster. Okay. Let's check like what are the labels here. Okay, just to check the labels. Okay. Dot. So these are the methods. I mean, just once you write this code, no, I mean directly by just by running it, you will get the like what are the labels you have written, label names. Okay.
So K means
Okay. Yeah. Yeah. Again and again. Okay. So once you, I mean, you will have to obviously type a label, then you will be able to see what is the label. Okay. If you guys want, I can also write. Okay. Okay. So these are the labels like 0 and 1. So yeah. Okay. Cluster 1. Let's take the all where the labels are 0. Okay. Okay. Uh, okay. Whether I have taken labels or label. Okay. It is label. Okay. Similarly, let's take C2 to those. Just run it. Okay. So now we have clusters. Okay. Now let's move to the plot part. I think you would be already aware that what it will do, right? Maybe yeah. No, I think yeah. This way we will be able to plot the all the 0 and all the 1. Then maybe let's use different color for both. C equal to, let's take red only. Okay. Or okay, just put the label name also.
Sir, C1 of colon 0 will put
Yeah.
all the points.
Okay, yeah, we can do that. Just give me. Okay, I think whatever is coming to my mind, I'm just doing that. Let me do. Okay, then maybe if we need to tweak it, we will do. Okay, all right. I think any other changes? Not okay. Let me see. Let me see. Okay, but yeah, one mistake I'm able to see here. Yeah, obviously it should be parenthesis, not the square bracket. Okay. So you are seeing that what is happening here. So I think we have a different this one. What do you say? I think yeah. All the points like what we are saying that these are in the different say different groups. Like okay, here we have red and here we have green. The way it is there here in this case, right? Okay. Now let's see what will happen if we take the center as 3 which what all center like 2 comma 3 comma 2 and 3 comma 3.5, right? Okay, let's change. Okay, for cluster 1. Okay, 3 comma 3.5, and for cluster 2 let's take what value yeah 3 comma 2. right? Let's run it again. Okay, see this. What is happening? You are getting different color. I mean, yeah, different groups for both cases, right? Oh, above points are inside. I mean, on another line. On I mean, think yeah. These are on another cluster, and these points are on another cluster,
So both the
right?
options are correct. Option A and B.
Right. Technically, it depends on three cases. If I increase this change, if I change this size, I mean the length of these two lines. I mean the distance between uh this y distance, or maybe some this x distance. Okay. Or if maybe if we increase the data point. Okay. So everything can affect your final result. Okay. So this is what I'm saying. So here, if you take these points, and if these are your points, then it will change you the answer. Okay. I mean, do you guys did you understood, or I mean, or I should so other things also here.
So what is C1 of colon 0 and C1 of colon 1 doing
C1 of colon,
in the code? Yeah.
yeah, where?
So what is it doing? So it's this
Okay,
one.
yeah, this one colon. It is taking all the rows in column 0. Okay, so see, okay, so what happens? When you plot, you have, let's say, point 1 comma 0, 2 comma 0, 3 comma 0. All these points are there. No, let's assume this one. Okay, so if I write something like this. Okay, and this is 0, it simply means that all the rows, I mean all the values of x, but only like a first index of y. Okay, something like this. You should take it like this. Got my point? Okay, it is taking all. See here, what is happening here in all row, your this 0 is your label. Okay, and this is showing your, I mean this one dimension, your data values. Okay, so here in the rows, it is denoting data points, and this one is denoting your labels. Okay, I took all the all the data points which has label 0. Okay, and see, and like all the labels which has data point. I mean all the data points which has label 1. Okay.
Okay, sir. So you stacked
Yeah.
it like a matrix using.
Right. Okay.
Sir, if the data point spread was more, like instead of 1 to 6, it is 1 to 15 or 20, will it also provide this same type of clustering with the same
No,
centroid?
no, it will change. So okay, that's good to know. Okay, obviously, let's do it here. Okay. Okay, let's change this. So as I told you, anything you will change. No, I mean the distance between these two lines, the number of obviously number of samples, or obviously range of the values. If you change, everything is going to. I mean, every time you will get the different result. Let's see. Okay. So currently, what is happening? Even with the same data points, you are okay. Line. Okay, line also changes. Is it? Okay. Let me see. Maybe. Yeah, so maybe we need to look at our calculation. So what is happening currently, you see, if you take that point as a, I mean your if you take that point as a your initial point, then every time all the points will lie in a different line. Okay, this will form another group, and this will form another group. Okay, because what is happening, are you guys getting? So see, for k-means, it is like these points are very close now. Okay, so if you, what is happening, so we didn't see this one, that if you have you are decreasing the, so for k means ultimately these are just the points only, we have not normalized it, right? Are you
Okay,
getting my point?
yeah.
Yeah. So yeah, for that's why, I mean, for so that's why for every cases here you are seeing that they are keeping all these points in one group, and these points in another group.
So
Okay.
what is the centroid?
Okay. Centroid is again centroid. We have kept it same. No, I think yeah. Okay. At the final centroid, are you asking, or I mean the initial centroid?
Initially.
Initial, just this one I took as the initial centroid only, the center point.
So
Okay.
for the
Or
same
okay.
centroid,
Yeah.
clustering is
Right.
for different n.
Right. I think yeah. Just I think yeah. Thanks for correcting me. Okay. I think things will change. Okay. 3.5 was the highest point. Okay, then 2 was this. So let's take this one. Okay. I think 25 would be there, no? Okay, take it 25. Things may change now. I hope. Maybe it can be same also. Let's see. Okay. So even after that also, like, we are getting the same result. So as we are increasing the number of data points or number of range, still we are coming to the same points if the center if we are taking points on these two lines now. I mean one center initial point here and another initial centroid on this line.
Sir,
Right?
I want to experiment with another thing. So if we keep the same 1 to 6 the previously, but we
Okay.
increase the data points, like we give a spacing of 0.1, suppose.
Okay.
Then what will it be?
Let's do it. How much points you are saying? What do you?
0.1, 0.2, 0.5, anything.
Okay. Just let me do. Stop. Step. Okay. 1,6, so you okay. I'm giving the step size of 0.1 only. Okay.
Sir, it is. I
Okay.
think it has become 0.6 after one
Okay.
line
Is it?
2. I'm not
So
sure.
this
Okay.
won't.
No.
So this won't work. Range only takes integer values.
Okay. No. What happens? No. Okay. Let's see. See. This is the step size actually. Okay. Here. Okay. Uh. Okay. Float object cannot be interpreted. Okay. So. Okay. Let me see the code range. I think it has the columns. I mean step size also. Like let me check with how we like how we add step size in range. Let me just search it. Okay, let's see here only now. Okay, let's see it. Okay. Start comma step. Okay, it is not taking this one. No. Okay. So it is not taking float values. Is it? Okay. So it is not taking float values. So maybe we would have to change the code then. Okay. So currently, based on this code, like we won't be able to do that. But yeah, step size should be integer only. Okay. So we have the, I think the minimum possible value is 1 only. Okay.
No problem,
Or
sir.
yeah. Maybe just we can change the codes also. Okay. Instead of range, we can use other thing. Okay. Yeah. So every time we are seeing, okay, let's see other things also. Okay. Just see here only. So that I think, you will also see the, okay. Instead of this one, okay, just take the centroid as like the last point. Okay. Maybe this one, 6, 3.5. Okay. Let's take it. I mean, any points on the two lines. So conclusion is that if you take any points, if you're not only the centroids, if you take the any points along this line, no, I mean if your centroids are centroid lies on one centroid lies on this line and another centroid lies on this line, no, okay, then you are going to get this figure, okay. But if it lies here and here or any other places, okay, then you are going to get this shape. I think the one which we asked there in the assignment. I think this one. Okay. So what is the conclusion here? Is that if your initial centroids are taken on these two lines, no, I mean initial centroids C1 and C2 are in such a way that it lies on these lines, okay, then you are going to get this figure. If it doesn't, if both C1 and C2 does not lie on these lines, then you are going to get this figure, right? At least tell something, yeah.
Yes, sir. Yeah.
Okay, all right, then I think anything else would you like to discuss? Obviously, you can expect one question. I don't know where, but definitely. Actually, I was also thinking I had also I didn't do the calculation. So, but I was assuming that if I'm taking it at here, no, I mean then both will lie on a different line. I mean this type of shape we will get. But I was just now I also saw that yeah, even we take any point on these two lines, no, I mean still we will get this same figure only.
Yes, and
Yeah.
that is very like I do not know how they're doing it because as per the formula, if we calculate manually for this particular case, so when the centroid is 6, 3.5 and 6, 2, then I think it should. I don't know, but my assumption
Definitely.
is it
See,
should be different.
yeah. So see, if you do the calculation, no, obviously you will get the same. See, obviously we will get the same thing. But yeah, for now also like I was also assuming that yeah, it will. I mean, if we will do the calculation, we will get different thing. But it is not happening.
So even if so, there would be a case when so if you take the points like 6, 3.5, and let's take
1,2.
1, 2,
Is it?
right?
Yeah. In that case, yeah, obviously the shape will change. That is
In
what I'm
that case, we
assuming.
will have to get that.
Yeah. It will change. It will change.
Right.
Definitely, because like one point lies on this side. So ultimately, what is happening? No, see, if both points are like this, no, then only if one point lying here and one point lying here, no, if it is lying diagonally, then it won't work. Okay, then you will get this type of shape if both points are on diagonal side.
Also,
Because ultimately, see,
that
yeah,
makes sense, right? Because the perpendicular bisector of that line,
yeah, obviously,
is the horizontal line dividing those two lines, right?
yeah.
If they are not on the same x coordinate, then the perpendicular bisector will it will cut those two lines also and do different work.
Right. Okay, so I think yeah, one nice concept even I also just now saw. Okay, which I was not expecting that. Okay, but yeah, okay. Anything else? Would you guys would like to know, or would you? Okay, so one task would be there that just do the calculation manually for this one. Okay, maybe just take the 6, 6, 4, 2. We were taking no 6, 3.5 and 6, 2. Do calculation manually for that point. Okay, and see. I mean, then maybe better you will be able to see whether by mathematically you are able to do this or not. See, ultimately this is the result you will have to get, but just check it so that your concepts will be more clear. Okay. Okay, all right then. I think yeah, 33 minutes. Okay. Anything else anyone would like to say or discuss? Okay then. Okay then. Bye bye everyone. Yeah, I think that's all from my side. Anyone would like to ask anything or a?
No, sir. No.
Okay.